Hi everyone and welcome back to Matter for Thought. Today I have the absolute pleasure to host here the man that no superlative does justice with him. SciManDan, the stage is all yours.
In the previous episode, we saw how to disassemble a vector into its components according to its angle of inclination using the basic trigonometric functions. In this episode, we will get to know a new force and see how everything connects in a wonderful way. When we talked about ballistic motion, we were referring to the effect of gravity on an object that does a motion in the air until it hits the ground, with the ground always perpendicular to the force of gravity. The reason the object stops on impact and doesn't continue deeper into the earth is, of course, because the earth resists. Any such force that resists a continued motion by direct contact in the opposite direction to the direction of motion is called a normal force, and it is denoted in capital N. Its magnitude is the same magnitude of the acceleration vector at the contact point, and its direction is always perpendicular to the surface at that point. I know, it sounds complicated. So to see how simple it is, let's take a look at what happens to an object that is an inclined surface. We will currently deal with zero initial velocity in order to stay simple for now. In the simple case that there is no slope, the normal force is perpendicular to the surface, i.e. to the ground, and the magnitude is the same magnitude of the acceleration vector. So we have 9.8 meters per second squared down due to gravity and 9.8 up due to normal force, and they sum up to 0 round. This is why an object that is on the ground does not accelerate downwards, even though gravity is still acting on it. Now let's see what happens when the ground has an inclination. We already dealt with the 3, 4, 5 triangle before, so this time we chose something else. We will take a surface that has a slope of 30 degrees downwards, so let's see what forces act on a ball that is on such a surface, and accordingly, what is the magnitude and direction of the sigma f vector. The simplest part is of course gravity, with magnitude of 9.8 downwards, and if our coordinate system looks like this, then we can mark the gravity vector this way. 0 minus 9.8. In addition to gravity, a normal force also acts. Its magnitude, as we said, is 9.8, and the direction is perpendicular to the surface. So 9.8 to this angle, which is 30 degrees, equals 4.9 times square root of 3, equals 8.487. This is the magnitude of the normal force. Now let's disassemble it to its components. We will draw a triangle whose legs are parallel to the axes and the hypotenuse is the normal force vector, and we will see according to this what their magnitudes are. The horizontal component is the leg opposite to this angle, which is 30 degrees, and therefore a sine of 30 degrees is equal to half, which means that the size of the leg, or the horizontal component, is half of 8.4847, i.e. 4.2435 in the positive direction of the x-axis. The vertical component is the second leg, which can be calculated in several different ways. Just to show that they are all actually result in the same number, we will do them all and see that we get exactly the same thing. First method. So if the sine of that angle gave us this leg, the cosine would give the other leg. A cosine of 30 degrees is half root 3, which is 0.866. And when multiplied by 8.487, we get 7.35. Second method, if this angle is 30 degrees, then the other angle is 60 degrees. So a sine of 60 degrees is half root 3, which is exactly what we got before. A third method is the Pythagorean theorem. We calculated the first leg and we know what the hypotenuse is, so the square root of 8.487 squared minus 4.2435 squared equals 7.35. Thus, the vertical component of the normal force is 7.35 in the positive direction of the y-axis. Now we will sum up the forces. 0 minus 9.8 add 4.2435 73.35 equals 4.2435 minus 2.45, which looks like this. That is, the ball experienced an acceleration of 2.45 meters per second squared downwards and an acceleration of 4.2435 meters per second squared to the right. Is that angle familiar to you? Exactly. See how simple it is? In the next episode, we will do one combined exercise that includes most of what we've learnt so far, and after that, we will move on to the next topics.
Thanks, SciManDan. That was enlightening. I truly hope I see you here again in the future. And that's for today, friends. I hope this demonstration connected the theory to the deeds. Those who are still getting confused, my contact info is in the description. And if by some chance you don't know SciManDan, link to his channel is in the description too. Before I wrap things up, I want to thank my patrons. If you find the content good, a link to my Patreon is in the description. Feel free to like and share, subscribe to the channel, and please leave a comment. I was, as always, rndthinker, and see you in the next video.